So my name is Alex Godber here. I'm the Technical Fellow for Smart Factories at the Advanced Manufacturing Research Centre. So we're going to spend the next maybe 15 minutes or so just giving you an overview of who we are, what we do, why we exist, a brief introduction to MQTT and Sparkplug for the uninitiated, and how it solves some of our connectivity challenges as a research organisation. And then I'm going to give you an overview of some of the work that we've done internally at the AMRC to hopefully try and accelerate the adoption of Sparkplug within the manufacturing sector. So the AMRC, we're a non-profit, partly government-backed research organisation based out of the University of Sheffield over in the UK. Our main aim really is to take low-level, unproven research, sometimes directly from the university, but not always, and develop it and de-risk it to a point where it is of sufficient maturity to be adopted by industry. Typically, not always, but typically, research tends to be relatively cheap to prove out in a lab environment. But it's expensive to develop and de-risk to the point where industry are prepared to adopt it. So historically, there's been a bit of a disconnect. Our job as the AMRC is to have 1 foot in industry, 1 foot in academia, and try and align the two. And we do that by making the mistakes for both academia and industry in a sterile but representative environment. So we've been around since about 2001. So we're about 20 years old now. And we consist of around 500 active research staff across different sectors. So areas like machining, composites, materials, structural testing, castings, and connectivity and the industrial Internet of Things. If you're ever in the UK, in our neck of the woods, please come and see us. We'll show you around. We're really proud of what we do. Jeff can attest we do pretty good pies, right? But as we've grown, and you can see an image of our facility in Sheffield in the top right there, we've had a number of kind of high-profile manufacturers move in next door to us. So you can see Boeing, McLaren, and Rolls-Royce have facilities nestled amongst the AMRC buildings in Sheffield. And those aren't research facilities, they are their production facilities. And they were chosen exclusively due to the location and the proximity to the AMRC's research. So we're extremely proud of them. Now, as a high-value manufacturing research centre, typically, the research we did was applicable to aerospace and defence. But over the years, as we've conducted more digital-facing research, it's also applicable to other sectors like rail, the medical industry, civil engineering, automotive as well. And although we aren't a production facility, our main export is intellectual property, we do share the same challenges around OT connectivity as the vast majority of manufacturers. We have a whole host of weird and wonderful machines within our facilities. Very rarely two are the same, and we use the data from those machines frequently for research purposes. So you may have seen this before, I've stolen it from your website, sorry. But like most, as we grew as an organisation, so did our digital requirements. And coupled with the rapid acceleration of digital technology in the last kind of 10 years, we ended up with solutions that were kind of organic, lots of point-to-point connections. They didn't scale very well. It was very Frankenstein-like. A new technology would come along, would bolt it on, and again and again. And it simply wasn't fit for purpose. So not only from an operational perspective, but also as a research organisation that others look to for best practices, it simply wouldn't do. So we set out to standardise the way that we connect to our OT and IT equipment within the organisation. And doing that not only, again, from an operational perspective, but also so that we could document that journey and hopefully allow others to follow in our footsteps for things that went well, and to not make the same mistakes as we did for the things that didn't go so well, which there were many, just me. So we did quite a lot of intensive research, and we came across these three principles which resonated with us. So the first one is report by exception, and I'll dig into these in a few moments in a bit more detail. So the first one, report by exception. The second one, connect to infrastructure. And the third one, be edge-driven. And these really would form the cornerstones of our architecture that we would then go on to deploy. And it became apparent that if we adopted these principles, the architecture that resulted would be lightweight, scalable, and performant, and ultimately fit for purpose. So the first one, report by exception. So this is the concept of, rather than asking a device, a sensor, for its value, we allow it to tell us its value when that value changes. Now, there are obvious benefits in terms of kind of network bandwidth for this, especially if you've got devices out in the field where network bandwidth is a premium. But the one that resonates with me is the ability to have theoretically higher resolution data from your machines. So if you're polling a device, you have to decide on a polling frequency, right? And that is theoretically the highest resolution data you're going to get from that machine. If you have devices out in the field, maybe once a minute, once an hour, once a day, depending on your network bandwidth. If that value changes within that window, you're only ever going to get the latest value. With report by exception, you get every single value every time it changes, using only the amount of network bandwidth it requires to transmit that new value. So principle one, report by exception. Principle two is connect to infrastructure. So the idea of having something like this, turning into something like this. The diagram on the right is simpler to maintain, easier to manage, easier to secure, and significantly easier to onboard new devices. So a good analogy to this is when you go to a website on your laptop, BBC website, CNN website, you don't plug into their servers every time. You connect to an infrastructure, you connect to the internet. And that's what we're trying to get to here. So principle two, connect to infrastructure. And the third one, be edge-driven. So this is the report from report by exception. So benefits include improved security. So rather than having to open a port in the firewall to allow a request to come in to ask for a value, the edge device simply broadcasts the value when it changes. So client-initiated, edge-driven. And it's ideal for low-power devices. So if we go back to the diagram on the left, if one of those devices on the bottom row there on the diagram on the left had to respond to, let's say, 10, 100 things it cared about its value once a second, it's responding to the same question with the same answer 100 times a second, rather than doing its job, which is to monitor a process. With an edge-driven approach, the sensor, the device, monitors the process and informs the broker, the infrastructure, when that value changes once. So third principle, be edge-driven. So most of you will be familiar with what MQTT is, but effectively it's a protocol for IoT communication. Pub-sub, publish, subscribe based. So the general idea is you have an MQTT broker in the middle, or a set of MQTT brokers for redundancy. You have data producers on the left, which will publish a value to a topic, an area on that broker. And then things that care about values, subscribers on the right, will connect, register their interest in a topic, and receive the data when the subscribers send that data. So MQTT was originally developed in the 90s, and it was used in, is it Philips 66? Oh, yeah. More recently, industry has started to adopt it. And quoting Arlen earlier on in the presentation, it was designed to keep it simple, stupid. So very flexible, no payload definition, no topic definition. You can define that however you want based on your application. But as it started to be used as kind of a standard protocol within industry, different people used it differently. So the analogy I like to use is we have MQTT, we have a method to communicate. So we have a telephone, we can communicate. but I speak Mandarin and you speak French. We can physically hear each other, but we can't understand the words, the packets. So that's where Sparkplug comes into it. So I appreciate I'm preaching to the choir here a little bit. Most of you will be familiar with this, but if not, we can share the specification. If you Google MQTT Sparkplug, it'll be one of the first results. But ultimately, Sparkplug is an open source specification that lays down the rules for how to use MQTT within an industrial manufacturing environment. It defines a payload definition, so what the packet should look like. It defines a topic structure, so where those packets should be sent to, and it defines a state management model. So now, going back to the telephone analogy, we have the use of a telephone, we can physically communicate, but also we now both speak English. So as the AMRC looking to deploy a standardized architecture, having both of these documents, we have MQTT, and we have a theoretical way to deploy MQTT in an industrial environment with Sparkplug. Fantastic. Now what? Sparkplug does a really good job of defining what, but it doesn't necessarily say how, and that's by design. So at the AMRC, we implemented Sparkplug, and we documented that journey, and that turned into an open access framework, which we call Factory Plus. So this is a public web portal. You can visit the URL, you can scan the QR code. We welcome feedback. But it's an open access framework that defines how to practically establish a unified namespace using Sparkplug within a manufacturing environment. So yes, it covers what Sparkplug is, what MQTT is, how it's used, but it also covers things like network infrastructure, containerization, orchestration. How do we deploy those containers to the edge and centrally? How do we upgrade them? How do we fail over? How do we scale? It defines infrastructure as code best practices, so taking best practices from the IT domain and bringing them into the OT world. It defines data schemas, data models, protocols and encoding, which is the Sparkplug element, device management, edge connectivity, historians, long-term storage, sending and receiving commands with authorization and authentication through Sparkplug. And then recently, we've added a whole new section to outlining how we consume data ultimately collected by Factory Plus and Sparkplug, which we call the consumption framework. So the idea here is that Factory Plus is a start to finish manual, really, for deploying Sparkplug within an industrial environment. So I'm now going to hand over to my colleague, John Hall, who's going to show you how we're really practicing what we preach and how we've deployed Sparkplug via Factory Plus at the AMRC and what we use it for in a research setting. Over to you, John.
Hi all. So Alex has spoken about the reasoning behind the way that we've deployed Factory Plus, the building blocks that we've used. What I want to talk about is a little bit more focused on the actual deployment, how it is deployed across buildings, what we're using it for, and what I'm really excited about is some of the research that Factory Plus has enabled within the AMRC. So with that in mind, Factory Plus, that's fine, sorry. So we started using Factory Plus as an operational tool based on a lot of the tools that we've been hearing about, talking about this week, Ignition, Sparkplug, Canary. All these things are implemented to help us to collect data, communicate with machines, share data across groups, across buildings, and it means that we now have more ways to access, more ways to use the data that we have already being reported by all of these machines. The first port of call for a lot of this, once we've connected a new machine, is to create a dashboard for it. So we can see we've got a few examples here of dashboards for 3D printers, furnaces, filament winders, all personalized to be displaying the data that is key to that machine, the data those operators want to see. And yeah, those are customized to be exactly what they need to be. So the deployment itself is, in summary, Factory Plus is deployed across 7 buildings on 4 sites across the UK, all over the AMRC in its various incarnations. And using Sparkplug means that when we want to connect a new device in one of these sites, it comes down to a simple checklist. Physically, where is the device? What information is it reporting? And essentially, what protocol is it talking? What translation is needed to be done? So that's also enabled us to connect a wide range of devices. As Alex said, we have a weird and wonderful array of things at the AMRC, and a large number of those are now connected to Factory Plus. On the extremes of that, we have a 60-year-old lathe in the bottom left corner of the screen there that obviously in its initial construction has no sensor capability built in. So that's fully retrofitted with vibration sensors, power consumption sensors, temperature sensors, all these things to enable us to gather data from that extreme legacy machine, package it into a Sparkplug payload and report it up to Factory Plus. On the other end of the scale, we have a KUKA Titan, which is the next picture to the right from the lathe, one of the largest payload robots commercially available, controlled by a Siemens 840D PLC. And using the same methods, we've been able to connect that very high-tech modern machine into our network and collect data from it. You may argue that's much better quality data, but that's not for me to comment on. So, and the other thing that we've got on the screen here is, just as I've been talking, on the right, we've just got an example of a visualization of the network using Shifter. So we can see birth messages popping in from all the devices that we've got active, and just at the end there, that's a sort of example of the standard traffic going across the network. So we've got payloads being reported on all these different topics, just pinging back and forth all day. It's quite hypnotic to look at. I just have it open on a second screen sometimes, just to relax me. So moving on from that into some case studies, and you'll have to excuse me for looking at notes because this isn't my work and I kind of want to do it justice. So the first thing I want to talk about is a project from our composites team that was looking at the adaptive control of a composite cure. And essentially what we have is an oven publishing its temperature data over the MQTT broker that's being subscribed to by a control application. Oh, sorry, I'm looking at the wrong screen. So that control application subscribes to the temperature data based on live temperature data, historical temperature data, and some information about the component that's being cured. It's able to extrapolate the cure maybe 10 minutes into the future and generate a oven power output that will maintain the cure temperature without overshooting, causing the problems that come with that. So that power output goes through what we call the command escalation protocol. That's something that we've generated within Factory Plus. As some of you might know, within Sparkplug, only the primary application can send commands. But in this case, the control application issues a command request to the primary app and says, I want to tell the oven to set its power output to 80%. The primary app can check the permissions of the control application. If everything checks out, that command is sent onto the oven. So we have remote control of the oven based on a much more intelligent control algorithm than the one that's inbuilt into the oven controller. And just to give you the headlines of the results of that work, we ended up with a 70% time saving and a 50% energy saving compared to a standard curing process, because we were able to cure at higher temperatures for a shorter time because of that live monitoring and the more active control of the oven. One of the things that I love about this project, it was actually proposed by the composites team. They came to us and said, we want to be able to do this. We want to be able to remote control one of our ovens. And because of Factory Plus, we were able to say, we already have the infrastructure to do that. We just need to connect the oven into it, and then all of this is possible. And it's a great feeling to be able to say that. Took a lot of work before that, but yeah, made things easier. So yeah, we've got a genuine pull from the research teams for this capability, for this level of connectivity that we've got. The next case study then, and this is where I really need my notes, is looking at using a neural network approach to more accurately predict the cutting cycle times for a robotic machining cell. This is something that is possible through simulation, But in general, what you see is an underestimation of the lead time because the simulation doesn't know the physical attributes, the limitations of the robot that you're using. So, as a lot of you will know, the starting point for any AI research is going to be acquiring large amounts of high-quality data. You need that training set, you need a testing set, and you need to be sure that all of that is high quality. And using Sparkplug, we were able to generate that data, a structured data set from essentially automated trials. So with data having all of its context from the edge, we weren't having to worry about collecting the data, then contextualizing it, then storing it. That was all just being done on the network. So it almost became a set of lights-off trials. The robot was doing its thing, data was being collected, stored. When it came to analyze, that just had to be pulled down from the historian. And Tim, one of our AI guys, did whatever he does. And we were able to get some really good results out of that. But the takeaway for us from the in the connectivity team was that using IoT, we've created this environment where AI research can easily be carried out. And one of the interesting things is that all of the data from this persists in the historian. So in future projects that may be in a similar area, those physical trials may not even be necessary. It might be that we have the data, we already have a data set to start with, and that project can be done in half the time, potentially. So moving on to our last case study, we have a zero-knowledge digital twin application. The idea is that we have a consumption framework that sits on the network and provides contextualized data to the consumer of that data, to the person creating and observing a digital twin. So the supervisory digital twin requires no prior knowledge of the cell that it's a twin of, and 3D models and metadata, as well as how they should be used, are pulled dynamically from the network, and at the same time, live data is subscribed to from the cell. Those are brought together, so it means that you are visualizing that live data with context that has been pre-written, that has been provided by the consumption framework. So when you have a set of 6 numbers that are all your axis angles that have come from a robot, rather than looking at that as a set of 6 numbers, that has been visualized based on the consumption framework and using the CAD model of the robot shown as the actual position of the robot, as if you were looking at the actual cell itself. So the consumer of the data doesn't need prior knowledge of the system in order to see the information that they need. And that's the main takeaway from this one. So just as a final word on this then, Factory Plus is a pipeline that we've generated using, again, the tools that we've been talking about all week. And it's enabling us to exploit research data much more effectively. And it's enabling us to move into new research areas and enable a lot of that research that we couldn't do before. As Alex said, all of this information is available on the website. There's a QR code up there. It's also accessible through our badges. So if you find us, feel free to scan those. And our website is the Factory Plus website. But for now, thank you for listening.
Okay, so Todd Anslinger from Chevron. I'm going to talk kind of about the end user benefits of Sparkplug and joining the Sparkplug working group. So, you know, I don't know how many people in here are control system engineers, automation engineers? Okay, cool. And IT? All right, so really, or operations, whatever. So this is really kind of how I do it. You know, I break it down into what does it mean to me. So if you're a control systems engineer, okay, great, you're gonna probably relate with this. If you're IT person, now you're gonna know what the OT person goes through, okay? So that's what I'm gonna try to break it down. That's kind of my job, is break it down into speaking to who I'm talking to. All right, so, but before I talk about technology, it's gotta have a business problem we're solving, right? So what we're looking at Chevron, we wanna reduce integration time in the PCN, reduce integration time in enterprise business systems, extend the life of low bandwidth Ethernet radio systems. That might be a little bit tailored to upstream oil and gas. Avoid running blind on day one of property swaps or acquisitions. I'll expand that. Part of our goal as Chevron is to modernize our PCN, okay, and the value around that. And then we have some business units that say, hey, we're gonna double production without adding more people. So that means we have to do our work differently, right? We can't do it the same way we've been doing it. So before I ask this question of how many years we've been doing pull response in the PCN, I'm gonna break it down and say, what is pull response, okay? So the automation engineer, they create let's say they're adding a tank in the PLC, all right? After they add that tank object there, they go to the touchscreen, add that object, and say, hey, I want to pull that tank level every second, okay? Then they go up to the control room HMI, add the object there, and say, hey, I want to pull that tank level every 15 seconds, every minute. They go to the polling server and they say, poll, I want to poll every 15 seconds. You poll the PLC, you get a response, thus poll response, okay? So now I'm gonna go back. So starting at 10 years, who's been doing poll response in the PCN for 10 years, at least, or longer? Okay, 20 years? All right, 30 years? Okay, I know Wonderware has been around for 35 years, so I know it can be at least that. So, good, that gives me, let me set this right here for 35 years just to be safe. All right, everyone look right here. All right, now I'm gonna switch to the wireless mic. Since you've forgotten what you've done for the last 30 years, how do you want it to work? How would you expect it to work nowadays? All right, nowadays to me, I want it to work like this guy, right? You turn it on, give it an IP address, and it just works. It just shows up. All right, so that speaks to this here. So Sparkplug, let's say you have a Sparkplug compliant PLC. You create your object in the PLC, all right? And you draw your circle on the PNID, everything around that, you create that object. When you hit save, it pushes it up to the broker, all right? And then at the broker, the control room sees, oh, I'm subscribed to tanks. Automatically pull that in, put it on the screen. Your Pi server, I'm subscribed to tanks. Automatically pull that in, put it into Pi. My local touch screen, I'm subscribed to tanks. Automatically put it in, and put it on the screen. You do that once, and then, you know, if you're like Chevron, you go through a couple firewalls, broker to broker to broker, transit, and then get it up in the cloud. You do that once at the PLC level. Because all of us that have been doing this for 25, 30 years, what have we done? We create the object in the PLC, pump in the tank level, the pressure transmitter, the pump speed, all of that. Do that in the PLC. Okay, great, that's done. Go to the touchscreen, create an object, point it to the tank level, to this pump speed, to the pressure. Great, that's done. Go to the control room, create an object, point it to the tank level, the pressure. What are we doing? We're creating the same object 4 times. Oh, PI-AF, same thing in PI-AF. And then if we get that up into Azure, okay, maybe we can take advantage of the PI-AF structure there, but we're creating that object 4 different times. That's ridiculous. Okay, we want to create that once at the lowest level possible, and then boom, hit the button and it goes up. And you might say, okay, Todd, I've got old PLCs, they're not Sparkplug compliant. All right, well, talk to Don. He's got one Sparkplug compliant. You know, I can connect you with people that has that. Or you add on an edge device and you do pull response right there, and then it's publisher subscriber from that point. Great, we can talk about how you do that. But the point is, create it once at the lowest level and use that structure all the way up through to the cloud. All right, so what observations did Chevron make? We took a stopwatch and timed our trained integrators on how to do that. To make it sound good, we're calling it Lean Sigma time measurements, okay? So we took competitor vendor PLC, HMI, touchscreen, versus single vendor PLC, HMI, and publisher subscriber. And one thing I don't have anywhere else is we compared the bandwidth of across the radio, since we use a lot of low bandwidth radios. And since I don't have it anywhere else, we saw that poll response versus pub sub we used 15% of our radio bandwidth, okay? That'll come up a little bit later. But since I'm a visual person, engineer, here's the diagram of the architecture it looks like. The left are the same, it's just competing vendors, same vendor. Right side is the pub sub, and this is a 4-year ago type thing, so the architecture would look a little bit different. So, but the thing that I want to show there is the pub sub isn't really apples to apples to the poll response because you get the cloud piece automatically, all right? Automatically shows up on your phone. So what we did, we had a trained person develop, we had them add a tank object. So this was on an existing system, and we can extrapolate to a greenfield, which the benefits would be far outweigh. We added a tank object, linked it to the transmitter, did that in the PLC, did that in the touchscreen, did that in HMI, checked the box to push it out to Pi. Okay, done. 22 minutes. The single vertical vendor that has all those, take advantage of the common tag name database. I'm sure you've heard that, about half the time. And then pub sub, it was really just adding the tank object and hitting instantiate, boom, it just happened. So you can see in an existing system 20% of the time, and it's really just that person at the PLC in the field that has to touch anything versus your whole development community with the touchscreen integrators and control room integrators. So that was the Lean Sigma time measurements. So I want to get to now kind of wrap up why should an end user use Sparkplug. First one, it has a birth certificate and death certificate. So the birth certificate is important because if other pieces of software understand that birth certificate, which is part of being Sparkplug compliant, when it says I'm subscribed to all pumps, it sees a new pump show up at the broker, it automatically pulls it in, adds it to your drop-down list. Okay, so the birth certificate is really important for that reason. More important from an operations standpoint is session awareness. Okay, we talk about in the Digital Transformation Council, your successes are great. Let me hear about your failures, okay? So I'll tell you about one of mine 20 years ago. We were hooked to a saltwater disposal, and the operator's looking at the screens, 25-foot tank, the tank level is 10 feet, great. He goes there for a day and a half, almost 2 days. Tank level is 10 feet, it's fine, right? Well, I didn't have any built-in way to know if I was communicating to that PLC or not. Actually, water had went over and hit the transformer, knocked out the power. There was nothing on the screen that said, you're not talking. So I'm sure you've seen the signs driving down the road, little signs, if you, in case of problem, call this number. Well, the control room operator gets the call, hey, I'm driving down the road here and there's water going across the road. And the guy realizes, oh, it hasn't changed for a day and a half because the power's out. Stale data, so environmental spill, right? That's why the session awareness is so critical for operations, and even more so inside of a plant. So that's my session awareness story. It accounts for hierarchy of our facilities in the topic, in the tag namespace. So if we didn't have that, in Chevron's case, it would be Chevron dot North America upstream dot Mid-Continent Business Unit, Permian Basin, Dripping Springs facility number 1, whatever. All that would have to be buried, open it up, bury it in the JSON scripting. I'm no JSON coder. I'm not going to do that. I'm not going to ask anyone else to do that. That would be part of an adoption fail. So giving it that we can open that tag, pull that tag name and see all that context at the tag name level, big advantage. That's required actually. Sparkplug has been given to Eclipse Foundation to manage an open standard with other companies from varying industry segments, which means it's not proprietary, which means, I like to break it down, vendors will be able and interested in implementing Sparkplug because it's going to mean more sales for them, right? If we had a Chevron flavor of MQTT and we said, hey, Rockwell, hey, Emerson, please use this, please put this in your product, that's not going to increase their scales. They're going to politely say yes and then go down the road 8 years and nothing's happened, all right? So very important. And I kind of equate this to, remember Alan Bradley had ABCIP? They gave it to, that was Alan Bradley. So Emerson wouldn't do it. Other people wouldn't do it. Well, they gave it to ODVA, and it's now called CIP, Common Industrial Protocol. Now everyone adopts it because it's not proprietary. So same thing here. Very important that it's not a proprietary protocol. Which leads to the next one. Vendors have Sparkplug compliant PLCs right now. I don't know if you've heard, in the few that I was set in over the last couple of days, just about everyone said, I'm using Sparkplug. So very important. And PLCs can do it now. All kinds of edge devices can do it now. And then with the Sparkplug committee, having the test kit already there to validate that how compliant they are with the current spec, we don't have to spend time verifying the validation, right? So another big piece that is already handled for you. Common specification. So this one here is my ploy, not ploy, Todd's wish, maybe not Chevron's wish, Todd's wish that Sparkplug would be the new Modbus, all right? Everyone has Modbus in the field. If, we do a lot of property swaps with, let's say, Oxy in the Permian Basin. When we swap with them on day one, we don't have our SCADA system built out to there to talk to that site, right? If Oxy had Sparkplug on there, and granted, they're gonna have different objects than we have, I understand that, but if they had a cellular connection, we could just spin up a broker in the cloud, point it to there, and we have those tank levels coming in, the day we take control of that facility, instead of having the operator drive out there every day to make sure the tank level is not going to overflow before the next day. So again, I'm trying to break it down into work process changes, but that would make it easier to where we could quickly publish it and get all the data coming in without having to go 40,001, 40,003, 40,007. So, which we can do, but just takes 150 times the time. Low bandwidth usage on a radio system. So you saw that I said 15% bandwidth usage from pole response. So we've kind of tried to skirt around that, for years with, instead of, around one tank level, you're gonna have alarm high, 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 low, low, low set points. The discretes for the alarm could have a P&ID loop parameters. So what we do is we break it into fast pole, medium pole, slow pole. Fast pole, we get that tank level coming every 15 seconds, all right? Medium pole might be our alarm discretes. Okay, we'll pull those every minute. Then slow pole is gonna be your P&ID parameters, your set points, that type of thing, to try to get around that bandwidth so we don't have to upgrade our slow Ethernet radios. Now, I say low bandwidth, it could be poor connectivity also. If growing up, you probably dealt with this if you're upstream. Your PEs are looking at these nice trends, boom, 0. What did that mean? We lost communication to the facility. We spent a lot of time chasing that. Sparkplug has store and forward built in. You lose communication to your facility, when it comes back, it backfills that data. So no zeros in your trends. May seem trivial, but very important for operations. And then, of course, the last one. Your data just shows up when it's instantiated at the lowest point, which is part of our modernization of our PCN that we want to get to. So that's why to use Sparkplug. Now, why to join Sparkplug? All right, first one, drive the functionality of an open standard. All right, add your piece into it. If it's valuable to other people, we're going to make the change. For instance, I know Jose called and said, hey, we need to add a file transfer into this for this file. And we were like, okay, yeah, we see the value in that. Let's go ahead and do that. It didn't take one of a Chevron person to do all of that, all right? It's an open standard. We saw the value in it, so therefore we go forward. Next one is you drive the open standard for a fraction of the cost of paying someone a salary to create and maintain your own flavor of MQTT that no vendor will adopt, which is hashtag not plug and play. So, you can imagine paying someone $200,000 a year to create and maintain year after year after year. That's a waste of time and money, especially if that guy goes to work for Google, right? Because they will eventually when you don't give them something fun to do. So have, or AWS, sorry if you're AWS. So that's the value. That's why do it. And then, you can click there, raise your hand, Frederick, talk to Frederick to join. And now I'm going to reverse flashy thing you.
But let me introduce the people who you haven't met yet. Arlen Nipper from CirrusLink, right? Arlen is one of the 2 original developers of MQTT, so he speaks with some authority on that topic. Benson Hoagland is with Opto22. We have Frederic Debian, I probably don't say it right, but from the Eclipse Foundation. He's a Canadian, but it's a global organization. And then last but not least is Kevin McCluskey. So what I'll ask is if you folks who have not presented could just briefly talk about what you are doing and what is your connection to Sparkplug or MQTT? I guess Arlen should be. Yeah, you have to make that brief in your case, I guess.
So, hello everybody. I'm Arlen Nipper. I'm the CTO for CirrusLink Solutions. I'm also the chair for the Sparkplug Working Group. First of all, I want to thank AMRC. That was a fantastic presentation. I've seen Todd's before, but I really got to accommodate you guys on what you did. It was pretty fantastic. So, I invite everybody to find out what the Sparkplug Working Group is, find out what we're doing, look at the press release on being able to have a technology conformant kit to test your MQTT client implementation so that Todd knows that when he gets that driver from you, it's going to be compliant. It's got a Sparkplug logo for it.
Hello, everyone. It's good to see everybody here on a Thursday, late Thursday. My name is Benson Hoagland. I am Vice President of Product Strategy at a company called Opto22. We're a hardware manufacturer. We're one of the PLCs that Todd described. And real quickly, I've been with Opto 28 years, and about the first year that I came to Opto in 1995, we were already underway on a project to try to solve some of the problems that we're describing now, but problems of the day. And that problem was, how do we get plant floor devices to communicate on an IT network using the Windows operating system? As a result of that, in 1996, we co-developed and founded the OPC Foundation. So Opto was one of the initial developers of that, again, to solve problems at that time. And there's been a lot that's happening in OPC arena, we all know that, but the problems that we face today are different. And that's why we're involved in the Sparkplug Working Group and why we've been shipping products with Sparkplug B natively built in and with Ignition on those systems for several years now. So that's our role.
All right. Is this? Yeah, thank you. I'm Frédéric Desbiens, so you are close enough. And I manage IoT and edge computing programs at the Eclipse Foundation. So my role there is really to create an environment where those guys can innovate. That's literally my job description. So essentially, I keep an eye on a number of open source projects that we have in the IoT edge space. And Sparkplug as a specification is one of those. And then on the other side, part of my job is also to evangelize the technology and specifically put it in front of new audiences. One very important thing about what we do is really the vendor neutrality in everything that we do, in the sense that we are this vendor neutral steward for Sparkplug as a technology, and we own the trademark and we own some things on the behalf of the community, but ultimately it's those guys who drive the show. It's those guys at the technology level that decide where to want to go, and it's my job to create conditions for that to be successful. So thank you for being here, and especially in this post-party day, to have the courage to be there. I really applaud you.
Yeah, and my name's Kevin McCluskey. I'm co-director of sales engineering at Inductive Automation. And if you take a look at the Sparkplug list of companies or logos that we've had on slides over the years, and you were to add all the different logos on there, I think inductive automation would be the first. So we've been involved with Sparkplug and with Arlen and his team from the very beginning. We have been involved with a lot of different projects that a lot of different companies have done, and providing guidance and working with them to help bring it to success. And obviously the Ignition software and our platform has Sparkplug built in as one of the things that folks, when they purchase a license of Ignition, they can just say, I want Sparkplug, right? I want the MQTT modules from Cirrus Link. And so we're happy to be here and happy to be talking to you guys.
Okay, great. I appreciate that very much. We have enough time, I think, so I'm going to ask a couple of questions that I can't resist asking, and then I'll quickly turn it over to the floor. But I wanted to start with Frederick. And can you explain, in particular, the governance of this project, what Eclipse Foundation is providing? You mentioned vendor neutrality, but and I'll follow that up with a question, because it seems to me that this is a specification, not a implementation. So I wonder why, what the relationship is there for Eclipse in the case that it's not it seems to me it's not an implementation. So could you talk about how the project is governed and how it fits into the open source world, if my impression is correct that it's a spec, not an implementation?
All right, so let's get into open source politics then. Well, the simple answer to this is really that at the Eclipse Foundation, traditionally, well, first, when we started in 2004, we were literally one project, the Eclipse IDE. Love it, hate it. That's fine, because now we have 420 plus projects, so plenty of good technology over there. Around 2011-12, we created the Eclipse IoT Working Group. And what happened there is that the very first projects we had were Eclipse Paro, Eclipse Mosquito, so a set of clients and an MQTT broker. So MQTT is literally in the DNA at the Eclipse Foundation. Now, the type of governance we have for projects is under what we call the Eclipse development process. And how this works is that essentially our projects have to follow a number of rules: being transparent, open to the community, and meritocratic. Okay, so each project at Eclipse as open source project has a project lead and committers who have authority over the repository where the code lives. And then it's up to them to organize. I mean, I don't have hierarchical authority. Of course, I can provide guidance, I have opinions, and I bounce ideas with community members, but ultimately it's up to them to decide where they want to go, as long as they follow the process, right? So sometimes we will remind them, hey, time for your annual review, please publish your roadmap and things like that. But that's the extent of my authority over those things. Now, in 2018, roughly speaking, we introduced the Eclipse Foundation specification process, which was a new thing. And at the time, we were taking over Oracle as the home to Java Enterprise Edition. So we created from the ground up a spec process to manage this huge set of specifications. I mean, you have no idea how complex this can be. And that's great. I don't have ITER. That's not my domain. Whew. Now we have a set of very mature processes to govern, those specs and the open source implementations that go with them. Okay, and so in the case of Sparkplug, they benefited from all of that hard work when Cirrus Link contributed the Eclipse Sparkplug specification to the Eclipse Foundation. Okay, so they deliberately took that step of, putting this spec into our hands. So at Eclipse, the specs are open in the sense that they are built in the open on GitHub. So you go there, you can see the in-progress version of the next version of the spec. And you've got the TCK, the Technology Compatibility Kit, so open source code that you use to validate your implementation. And all of that is built by the committers of the project, which is literally employees from Opto, Cirrus Link, Inductive, and IVMQ, and others. Okay, and all of that, comes from them. Okay, so essentially, open specification, and it comes also with an open source implementation, which is the Eclipse Tahoe project. That's a
Sorry,
very
is which project?
Eclipse Tahoe,
Oh, okay.
T-A-H-U.
Okay.
And once again, the initial contribution for that was from Cirrus Link, so thank you for that. And the relationship between the two is that this is not a reference implementation that has special status over others. We require at Eclipse, every spec must have at least one open source implementation. There can be several open source implementations that don't necessarily live at Eclipse. We know that at the Linux Foundation, for example, the Fledge project has a Sparkplug connector, okay, that they developed, and that's fine. But really, we require at least one open source implementation, and then any number of commercial implementations, or even other open projects like Factory Plus that build on the technology. And we own the copyright to the text of the spec, and we just, it's free to implement, royalty-free, free to redistribute. We just ensure that, once again, nobody takes it and then runs away with the trademark or does strange changes to the market. Once again, in the idea that we keep those guys from fighting. No, they are all good friends. We create a level playing field among those people to work on the spec and optionally on the implementation.
Okay, thanks, Frederick. I have one more question that I'll ask, and that I'll maybe throw that at Arlen. Can you characterize the working group and what you do? I think people here are familiar with kind of the working group concept, but can you characterize the working group for this and who's participating, who are the committers, that kind of stuff?
Well, the committers are so first of all, once you've joined the Eclipse working group, everyone that joins can have a committer that works in the committer. Now, other committers can come in and start committing, and then they can be voted in as committers and don't have to be on the executive team. The Sparkplug working group, you saw all the logos up there, Cirrus, Inductive Opto 22, HiveMQ, Canary Labs, AMRC. We have monthly meetings, bi-weekly, right? Seems like every week, but we have bi-weekly meetings where we review right now, our main goal was to take the Sparkplug spec that CirrusLink gave to them, that I initially wrote it all in Word and I was explaining the world, and we got it down to all the normative statements, and we cleaned up a lot of the word. And that we're trying to release, version 1.0 in the July timeframe, and then have a reference implementation that goes with that. That is what we as the working group are trying to work towards. Schedule that, get it approved, and get it out in the market.
Okay, thank you. Now I'm going to shut up and let people from the floor ask any questions that they want. I appreciate your forbearance. Okay, I'll give preference to an end user over ARC. Don Bartusiak, go ahead. Can you wait for the mic though, Don, so we get it recorded?
Thanks. Don Bartusiak with Collaborative Systems Integrations. So I've heard the phrase unified namespace, but I don't understand what it is. Can somebody give us maybe just a brief explanation of what unified namespace is?
Who's going to pick up that one?
Okay. So that actually kind of came out of the blue for me as well. Walker Reynolds is an integrator, does a lot of factory integration. I will have to say, 6 years ago, I did the first MQTT demo ever. I was at Inductive Automation. Nobody knew we had done MQTT engine. I said, hey, I'm going to connect to 500 PLCs, 250,000 tags, and we're going to get it all in less than 30 seconds. And we did the demo. So this one guy walks up on the stage. It was Q&A time. He didn't talk to me. He grabs the mic, turns around to the audience, and he said, "This is the future." And it was Walker Reynolds. And he ultimately started the Industry 4.0 group, and he started this whole notion of a unified namespace. What that means is that using MQTT, maybe not necessarily Sparkplug, but using that, you build a topic, because the way you publish information is you want to be able to subscribe on a known topic and then be able to discover everything. That's where the plug and play comes from. So what the unified namespace group are doing is saying, hey, we should use this use this topic namespace, use this tag name structuring so that every time we add a device, it's just going to come in and populate. And that's going to be unified across our factory. Now, they're not dictating it, so strict. They're saying each customer gets to pick the best way that they want to do their unified namespace based on what they do. So if I look at Phillips 66, I know that, well, we've got the topic namespace of a pipeline, so it's pipeline 1, and then it's booster station 1, and then it's PLC 1, and then it's process variable 1. But if I'm in a factory, that's probably a completely different unified namespace. Does that answer your question?
That helps, Arlen. Thanks.
Okay.
Okay, next question. Peter, I'm gonna go over there. I don't know who that is. I'm ignoring my colleague. So please identify yourself and ask your question.
Ramses Verbrugge, Dow. Very interesting presentation, so thanks a lot for all the details that you shared. And I have a question. I've seen MQTT before and very interested in the technology. And I wonder, how do you position yourself compared to things like OPC, which also kind of overlaps, I suppose, with what you're working on? So
I try not to get into an MQTT versus OPC UA because I think we need and will have both technologies going forward. We use OPC UA all the time, to Todd's point and to Benson's point, is that OPC UA for brownfield equipment is going to be around for the next 20 years, at least, right? So we're saying that there's a right spot to say, let's go from, closed loop, very fast polling, or anything that you would do with OPC UA versus having this one-to-many architecture where you just publish things. I don't care who consumes it. And then on the other side, I subscribe, but I really don't care where it came from.
And in our perspective, we are technology agnostic as well. So we have Eclipse Milo and OPC UA implementation at the Eclipse Foundation, which comes from inductive automation. Great work by Kevin Aaron there, among others. And ultimately, it's up to the market to decide. Not me, not ultimately you, but collectively, what makes sense for a specific project and a specific implementation. So, of course, we have a vested interest in Sparkplug. We created this working group because we believe in its potential. But ultimately, we will work with other open organizations like ourselves, and we will take wherever our committers take us. That's our mission.
Okay. Go ahead. Somebody else wants to contribute?
As a long time implementer of OPC, I can tell you that I believe that OPC is an important part of this process. The reality of the world is we live in a brownfield environment. And as Arlen just described, OPC is going to be out there for a long time. So when at a local level, that's what we use. We use OPC to talk to an Allen Bradley PLC or a Siemens PLC and be able to pull all that data, model it, and send it into infrastructure via Sparkplug B. But OPC is a key component of that at that local level. So that's where we benefit from it. And in this case, we also use Ignition and their drivers, which takes all those tags, makes them OPC, model it, and send it on up into infrastructure. So it's still an important part of a complete solution.
Okay, next question up here. Peter, you didn't raise your hand that time. Okay.
Hello, Roberto Pena with DuPont. So my question to you, and really to any of you, as you said, we've got a lot of brownfield facilities out there. What have you seen as business justifications for either integrating or to even transitioning to MQTT, type or Sparkplug type devices?
Well, let's start. We want to start with Todd. Is that okay?
Yes. So the value that I see of doing that is being upstream oil and gas. We've got SCADA towers everywhere. all right? We want to have quicker speed to all of those locations. Well, what's the cost of doing a radio upgrade to get that last mile to get, 10 meg a second capability out there? That's very costly, all right? If we can use the same radios that we have now, but reduce our bandwidth to 15%, we add a $500 to $1,000 edge device on top of the PLC, convert it to Sparkplug, and do that, reduce our bandwidth over there and put it to a broker. We don't have to spend time upgrading our radio systems, all right? It's an Ethernet-based protocol. It's already there, it just happens. So it's a lot less time, work, and money to do that than the alternative.
Anyone else? That question was addressed to everybody. So does somebody else want to comment on the types of installations? Maybe
Alex?
Benson or
What about you in the
or Kevin?
So I'd like to echo what Todd said, really. For us, it's all about how quickly we can onboard new devices, right? We have, as I said, we have all sorts of devices, different protocols. Being able to convert them to Sparkplug at the edge and not worry about the rest of the architecture is a game changer for us. And as well, looking forward, scalability. So our partners we work with are looking to roll out digital architectures across their organization, and having one that is lightweight, flexible, scalable, like Sparkplug, is really appealing to them.
One thing that we've seen from inductive automation, we work with a lot of customers who are using Sparkplug, MQTT, and OPC and other technologies. As was mentioned, one of our developers is the main developer of Milo open source OPC UA stack, and we were one of the first companies to actually implement OPC UA outside of the reference architecture that they created. So, we've been working with that for a long time. I've seen a lot of folks taking a look at their infrastructures, and rather than thinking about replacing the pieces that are already there, converting everything over to MQTT and Sparkplug, just taking a new system. So if they're putting in something new over in this area, to take a look at the communication protocols that are in that section and say, oh, we're now reevaluating, should we be using Sparkplug? Should we be using MQTT? All right, maybe let's give it a shot over here, see the value that we get out of this. We understand the conceptual value that has just been talked about here, right? What do we actually get as business value? What are the dollars and cents? What's our return on investment? New project, new communication technology, and then maybe it does make sense to roll it out to everything else. But at that point, these companies are being able to see some of these numbers and be able to see what value their engineers are getting, what quicker development. That's sometimes one of the returns on investment there, and then lower bandwidth, easier on the infrastructure, that type of thing too.
I will add, there's one thing that our customers gain tremendously from an implementation of MQTT and Sparkplug, and that was their need to address cybersecurity. Doesn't really come up as much as you might think when you're talking about MQTT, but let's remember, OPC or many other technologies out there are traditional client server. You have servers out there on a network, and they're listening. So security obviously becomes very important. The beauty of MQTT as a pub-sub model, I get to publish data into infrastructure without opening any ports. So right out of the gate, my cybersecurity footprint is far simpler, far easier to implement than traditional client-server architectures. So that's been a big deal for our customers, knowing that they can protect their systems, yet still democratize all the data from those OT systems into infrastructure for any software to consume.
The other thing I want to add to that is the modernization of the PCN. If you don't do the pub sub in the PCN, I was talking about property swaps, we could take that and, when are we going to control from the cloud? I don't know. But at least you could, if you don't have the infrastructure available, you can point it to the cloud, and over a cellular connection, you're not going to get killed with data charges, right? That's one. But it's just having it there ready to go and be an enabler for the future rather than having to try to catch up, because you're not going to pull Modbus tags from the cloud down to there. If you have no other options for connectivity, this gives you that piece that it's a really repoint and you got the data.
Okay, back to the floor in the back. In the left rear, we have a question.
Yeah, Arlen, you can speak to some of this, but
Just please identify yourself.
my name is Alan Ray. I consultant. We'll go with that.
Fair enough.
So one of the things that we ran into, myself and Doug Miller and a few others, as we were working through edge connectivity, the security that we get to be able to really be able to lock down incoming ports, have a persistent out where you're really meeting that Purdue model, is great. Here's the problem. Everything I publish and I say, this is writable, if you have the URL, the username and password, I now can make a change to that tag back down at the edge. So we went through some work with Inductive and was able to validate that. But what is the roadmap for Sparkplug B to, because I don't think we played any games, and Kevin, you may know this, but I think what we achieved was good, but what's that look like for the identity management at the edge with rights with Sparkplug B?
Well, that's a question for the team, I guess.
What we did was that the extensibility of Sparkplug, what you're talking about, we'll probably kind of go low level here. It's called a D command within the Sparkplug verb. So a D command is using the Google Protobuf payload, and that D command can contain as much other metadata as we want to. So what we're able to do in your case with Ignition is be able to take the operator's credentials that sent the command and then add that to the D command payload so that when it got to the edge device, we were able to validate that the person sending that command actually had permission to send it and then go ahead and execute the command. Now that will be, we're trying to get Sparkplug 1.0 out the door, but that will be very easy to add that into the overall Sparkplug specification. And I think, to me, that's what's interesting with Sparkplug is that the payload is extensible. So we can add other metadata, we can add other properties, and still we don't break Sparkplug vernacular, if you will. To Todd's point, we added the ability to publish files, which means I can publish JPEG images, I can publish vibration data, things like that. We're looking at the D record command, which lets me do things like read pump cards and publish a block of unmutable data. All those things are possible within the Sparkplug specification.
Okay. And your roadmap, just to follow up on that, your roadmap is right now for second half of this year to publish
Right.
this spec. And
But anybody can
implementation.
go in there and do a pull request and say, I want to see this feed. That's the involvement within the Sparkplug working group, is that I'm sure, as you guys can tell, I've been in oil and gas for 43 years. I probably don't know that much about other sectors that I need to know. What do we need to add to Sparkplug to make it relevant for other industry sectors?
And yes, as you mentioned, Harry, we are introducing, we had a press release earlier this week announcing the launch of our compatibility program. So essentially this means that products that pass the TCK will get to use this nifty Sparkplug compatible logo as a sticker on the Benson's devices, or a little logo on the box. Do you still get it in the box when you buy Inductive? Anyway. So when you see this logo, and we'll have the full list obviously of compatible products on the Sparkplug website, you have the assurance that it fulfills all the requirements in the spec. And this operates like Sparkplug itself. Sparkplug is about simplicity, right? The full spec is less than 100 pages, and that's even if the character size is a bit big. So you can get it smaller. But simplicity for the spec and simplicity for the compatibility program, because essentially we operate on a self-certification model. So I would love to have millions of dollars and a certification lab and all of that. I don't. So what we do is that we put the TCK, which is open source code, okay, into the hands of implementers as a binary. So to pass officially the test, you need to get the binary because we don't want you to fiddle with settings. But ultimately, when you pass that, you submit a public statement that, you know, okay, the TCK gave me this file, okay, that says that I passed all the tests, and I'm making a public statement, legally binding, that I fulfill the requirements. Okay, so now you would say that maybe people will try at the margin to do weird things, but if they do that, it's about their public reputation. So this is what self-certification is about, the fact that people are making in public truthful statement about their compatibility, and then, you know, it's up to the market to decide. And ultimately, if something happens, we have a dispute resolution process and all of that around that to make sure that we resolve any weird situations that could arise. But we trust implementers to do the right thing. They get a fantastic royalty-free spec to implement as they wish. And if they want to claim compatibility, they just have to pass the TCK, and all of that is public and fully documented.
Okay, another question over here.
Sorry, just to...
Go ahead.
Just a quick comment.
You're welcome to. Go ahead.
As one of the people doing weird things in the margins, from an implementation standpoint, going back to the cybersecurity side of that, in the first instance, everything that you want to do as a node is defined in the birth message. So if a node, it has its credentials, it has everything, tries to do something, issue a command that it didn't say it was going to do when it first came online, that triggers a response from the primary app to say, what are you doing? You know, you need to rebirth yourself. You need to say that you're going to do that if you're going to try and do it. So there are things in Sparkplug to defend against that.
Okay, further questions? There's a hand over here. Okay. Didn't mean to take it away from anybody.
Shane Robin, Tampa Electric Company. Along a similar lines, we're still talking about security, and you guys have mentioned a couple times in some other presentations, no need to open ports, you know, that type of thing. Can you talk a little bit about how it transverses a firewall without, you know, opening the ports, and how do I sell this to my firewall guys that now are relinquishing control? It's like, oh, now I have no way of stopping what you're sending through.
So MQTT Sparkplug B, MQTT in general, does use a port for outbound comms. So you have one server, or in a redundant situation like the MRC guys described, redundant brokers, each of those is a single port in the system. That's 8883. At the edge, outbound is not inbound. So I can allow data to pass through. It's just like if you open up your laptop, you go to google.com, you put it in a search term. Google doesn't know anything about, you know, they can't get into your computer. They can't get onto your network because you have those ports closed. You've created a connection, you know, right? You gotta be a little careful with phishing attacks, but that's a topic for another day. But the point is that I can make an outbound connection, and with MQTT, we persist that connection, and that channel is TLS encrypted. So it's not able to be attacked from man in the middle or anything like that. And that's how we get state, that's how we move data, and in the event of a D command or something that has to come back through, back down to the edge device, that's how we do it. But no port at the device needs to be open for that. Now,
But you have to have a port to connect to the
broker.
Yeah.
That's, you know, a single port in the system, and IT loves managing one port, not 1,000.
A quick note for those of you who aren't familiar with TLS. TLS was mentioned. It's encryption for that connection. That's the same technology that your banking website uses. So when you go and you log in, and you know, it's encrypting that communication back and forth. It's an industry standard. It's something that IT departments like. So TLS 1.2 or 1.3.
Okay, we have some more questions, I know. So thank you, and hand over the mic. And that fellow there, that's Elko, I think. I've got a light in my eyes, I can't tell, but go ahead.
But the question changed. The question. My name is Ilko van der Wal. I'm the managing director of the organization PLC Open. And I just wonder, if you add so easily an object, how do you validate that? How are you sure that it is allowed and it's not part of a hack?
Oh, sorry. No. I was going to mention, so part of the communication, part of the client to broker communication, one, it's encrypted like we were talking about. It also has the ability to have username and password authentication that's part of it. But in addition to all of that, there's also the possibility of using client certificates. And that means that rather than allowing anybody to connect to the broker and be someone who's an unknown actor who's just sending something through and it's a hack, right, or somebody's trying to get into it, you can set it up so that that broker is only accepting connections from known actors that are outside of it, known systems that have client certificates. So you copy those around beforehand. That's a secured thing that you have secured on your network. It's not just sent over the network, and it's something that your security team controls. So those client certificates, it needs to verify that signature, that identity of what the device is that's connecting up to it, in order to do that bidirectionally. And that's an option. It's not required for every connection, but you can turn that on. And if you turn that on, that has even additional security there.
So you limit yourself a little in the flexibility. In the example from Chevron, where it's very easy to add an object in that sense, you have to redo your broker.
So either on the broker you would accept the client certificate, or you'd be copying that server certificate over as part of that communication as well. So you have a few options there, depending on which devices you're using and which MQTT servers you're using.
Okay, thank you.
And on the top of that, there are also access control lists in MQTT that you can use to add an additional level of, security.
And I think it should be noted as well that when MQTT was created, I'm really speaking for you here.
It's your fault.
It was KISS, right? It was keep it simple, stupid. So what Arlen didn't do, and Dr. Andy Stanford Clark, the other co-inventor of MQTT, is they didn't try to build a security mechanism into MQTT. And we haven't done that as well with Sparkplug B. We rely on TLS encryption, as we just described. In other words, industry standard methods for creating secure, authenticated connections between the devices that are communicating. And as we see progress in those TLS type encryptions and authentication methods, we benefit. The Sparkplug community benefits, the MQTT community benefits. So I think that's an important distinction. Rather than bottling it all up into the spec, we get to rely and leverage all the work that others are doing, including banks and so on that are using the same technology. We get to leverage that at a Sparkplug B level. Did I say that all right?
Yeah, you said that fine. Other questions? I'm looking for a hand here. I don't see one. No. All right. Now, I could ask one more question, but I'm really not going to do it because it's about 7 minutes before the forum is scheduled to end. So give me one last chance if you have another question. Oh, there's one. Okay, we got one more. Better to come from outside than from me. So go ahead.
Jeff with Canary. Arlen, I've had the joy of getting to know you well, but I've never asked you this question. At what point what was the pivotal moment for you where you and the team at Cirrus Link said, hey, we need to develop a specification for MQTT? Was there something special that happened, or what's the story there?
As you can imagine, the first payload, or the first topic payload that I designed was for Phillips 66. It was very efficient, and it was also so cryptic that I probably could have never documented it. So we had done the first MQTT module for inductive. It was just kind of generic. And I went to a trade show in Chicago, and Travis Cox was on a round table, and he said, oh yeah, we do MQTT. And then Moxa said, well, we do MQTT. And then Opto22 said, we do MQTT. And Hilscher said, we do MQTT. And so I went around to all those vendors, and I said, well, how do you do it? And everybody did it different. So as I always say, the great thing about MQTT, and the reason it's become so adopted throughout IT, is you can publish anything you want on any topic. The problem is you can publish anything you want on any topic. So the reason that we wrote Sparkplug originally was for our own sanity to say, look, we've been doing this for 20 years, lessons learned, things that we wished we'd have done that we didn't, and that was the genesis for Sparkplug, is to get interoperability, to get plug-and-play capability, and get MQTT back into the space that it was actually invented for in the first place, which was operational systems.
Okay, with that, I think we'll draw this to a close. I want to thank our presenters and our panelists for an informative session. And the forum concludes with a box lunch, so there'll be box lunches out in the lobby, and it's usually a very nice time for the next hour, hour and a half, or however much time you have to sit with your peers or friends you have made at this event and share lunch. So thank you all for coming, and please give this panel a round of applause.